Hello students, welcome to the new lecture, and in this lecture we are going to discuss about the chapter 6, okay, the structure of an atom in the physics. Okay, so in the physics chapter we have the sixth chapter, that is the structure of an atom. So in this chapter, first we are going to start with the introduction. So in the introduction we will see by the starting of this chapter we have the different models, okay, different models that we have discussed in the previous academic year. So in the last academic year, previous academic year, like ninth class, we have discussed about different models. Just we are going to look about it and not studying in detail, just for the idea purpose only, that's all. So they are J.J. Thomson atomic model, Ernest Rutherford model, Niels Bohr model of an atom, and so on. So these are the different types of the atomic models. So what is the importance of proposing such kind of atomic models? So the main reason is to study about the structure of an atom, that's all. So to say and to study about the structure of an atom, these scientists, they proposed their atomic models. So first, coming to the J.J. Thomson atomic model, he explained the atoms have negatively charged particles which are embedded in the positively charged regions. This is known as J.J. Thomson atomic model. So it is also known as plum pudding model. If you see here, this is the structure of an atom according to his atomic model. So atom is positively charged. It is positively charged, and also in it you can see the negatively charged subatomic particles are embedded, okay, embedded in it. So it is looking like a watermelon. If you see in the watermelon, the red color portion is like positive charged particles or positive charged region, and black colored seeds are like electrons. So these black colored seeds in the watermelon are they are scattered everywhere, okay, in the watermelon. So they are looking like electrons. So it is also known as plum pudding model. So this is said, such kind of model is explained by the J.J. Thomson model. Okay, J.J. Thomson atomic model of an atom. Okay, next is the Ernest Rutherford model of an atom. So this, according to him, this model is also known as nuclear model, and he said that nucleus is positively charged and the mass is concentrated at the center. So he said that the nucleus is present in the atom, okay. So around it there are some kind of shells and so on. So he said the electrons are going to revolve around the nucleus. Okay, what he said, Rutherford said, so the nucleus is positively charged and the mass is concentrated. Okay, the mass is concentrated here. The positive charged particles are present in the nucleus. Okay, the mass is present in the center, and around it there are electrons. Electrons are going to revolve around the nucleus like planets revolving around the sun. Okay, this is about the Ernest Rutherford model of an atom. Next, the Niels Bohr model of an atom. So according to him, the electrons are going to fixed in circular. They are going to move in a fixed circular paths known as orbits. So what Ernest said that electrons are going to revolve around the nucleus like planets revolve around the sun. And what the Niels Bohr is saying, he is also saying the same thing, but he said the orbit. He used the word orbits. Okay, what is meant by orbit? Let us consider this a nucleus, and around the nucleus some kind of elliptical paths are there. They are known as orbits. Okay, and Niels Bohr is saying that the electrons are going to revolve or move in the fixed paths. These fixed paths are circular paths. It is known as orbits. Okay, so he said that he said that the energy shells, he used the word energy shells or energy levels. So energy levels or shells both are same. So he said that this is one shell, second shell, third shell, and so on. So there is certain kind of energy is present in it. So certain kind of energy is present. Based upon the presence of energy, they have been divided into different shells, different shells. So first shell, second shell, third shell, and so on. As the shell number increases, the energy is also going to increase. So this is about the different models explained by the different scientists. Okay, so in it we have some questions. The first question is, can you arrange the subatomic particles any other way in the atom? So we cannot arrange better than the model proposed by the scientist. Okay, so next is, how do the subatomic particles coexist in electrically neutral atom? So here you can see the atom has three types of subatomic particles. They are protons, neutrons, and also electrons. Okay, so they have some kind of charge. Some kind of charge, and if you see, there is a nucleus. Okay, here there is a nucleus. The nucleus is nothing but, so it is present in the center of the atom, and the nucleus is going to have protons and neutrons. Okay, neutrons and protons are present in the nucleus of an atom. This nucleus is in the center of an atom. Okay, nucleus, the electrons are present around the nucleus. Let us consider the protons. Okay, positively charged protons and also neutrally charged neutrons. So they are present in the nucleus. This is the nucleus, and around the nucleus there are some kind of shells are there. So the energy shells, in it the electrons are going to present. The electrons are present in here. Okay, electrons are, or you can say electrons are present around the nucleus. Okay, so how they are stable, how the protons and electrons are going to exist together? So here you can see the protons has positively charged, electrons are neutrally charged. So the positive charge and negative charge, they are dissimilar charges. Okay, they are opposite charge. One is positive, one is negative. So if the charges are opposite, then there is some kind of attraction is there. Some kind of attraction is there between these two oppositely charged particles, and such kind of force of attraction is going to make the subatomic particles stay in this way. Okay, so here you can see the force of attraction between the protons and electrons make the coexistence of these subatomic particles in an atom. Okay, so this is about a few basic questions about the atom. So next one is the activity one. In the activity one, we are going to discuss about the basic things about the atom. So about atom, element, subatomic particles, atomic number, and so on. So first one is what is an atom? Atom, element, what is the difference? Both looks similar, but there is a little bit of difference is there. So atom is nothing but the tiniest particles that make up the element. For example, if you take a copper metal, or if you take a gold, so how they are made up of? They are made up of atoms only. Okay, if you take sugar, okay, so glucose, how they are made up of? They are made up of different type of atoms. Okay, atoms is nothing but smallest, tiniest particles that make up anything, whether it may be substance, whether it may be element or anything. That is known as atom. Okay, so if you see a small piece of gold, so gold is containing tiny, very tiniest particles. They are known as atoms. Okay, and what is meant by element? Element is nothing but any substance which is made up of similar type of atoms, that is known as an element. Let us take the gold bar. Okay, pure gold biscuit or gold bar. So how it is made up of? We are using the word pure, means it should contain all gold elements only. Okay, all gold elements, or all gold atoms only. All gold atoms are only should be present in it. So if this gold biscuit contains only gold atoms, then it is known as a pure gold, or you can call it as elemental gold. So element means any substance which is made up of only one type of an atom, that is known as an element. Okay, so here it is made here in case of pure gold, the complete gold bar is made up of gold atoms only. Okay, so here next one will be the subatomic particles. So what are subatomic particles? Subatomic particles are nothing but whatever the particles that you can see inside the atom is known as subatomic particles. Let us see the structure of an atom. So the atom has the nucleus in the center. Around the nucleus there are some kind of energy shells. Okay, these energy shells or energy levels are present around the nucleus. Okay, here you can see the nucleus is going to contain positively charged protons, and also neutrons are present. Neutrons and also protons are present in the center. It is known as nucleus. Okay, so along with it, another third type of subatomic particles are present. They are known as electrons. These electrons are going to present they are going to present around the nucleus. Okay, so these are the subatomic particles. Protons are positively charged, neutrons are electric, they are neutral, they have the neutral charge, and the next electrons are going to have the negative charge. Okay, so next is the atomic number. What is meant by atomic number? As you have the rule number in your class, each and every student have the rule number, so that is unique. Okay, only one rule number to the particular person or particular student. In the same way, out of 118 elements in the periodic table, each and every atom has a particular number. That number is known as atomic number. Okay, the number is known as atomic number. The atomic number is nothing but the number of protons. How many protons are there in the nucleus of an atom? That number is equal to the atomic number. Let us consider, if you take the sodium, okay, sodium atom, the sodium atom has the how many protons? 11 protons. Positive charged protons are 11. Okay, hence the atomic number of the sodium is 11. Okay, so that is the atomic number. So next is the shells. Okay, what is meant by shells? So shells are nothing but around the nucleus there are some kind of energy levels are there. These energy levels are shells. Here you can see this is the first shell, second shell, third shell, and so on. So as the energy levels increases, the shells are also going to get increased. Here the energy levels in the around the nucleus is known as shells. They are also known as energy levels. They are numbered as 1, 2, 3, 4, and so on. So here also you can see the first shell, second shell, third shell, and so on. So as the energy increases, the number of the shells also going to get increased. Or you can give the letters also. Okay, like K, L, M, N, and so on. So as the number of electrons increases, the shells are also going to get increased. We will discuss in detail about what is a shell, what is subshell, what is an orbital in detail in coming lectures. Okay. So next one is the subshell. Okay, subshell is nothing but, so each and every shell is going to have a subshell. Let us consider, you can see the nucleus, around the nucleus there are some kind of energy levels. So in each and every shell it is going to have the subshells. Here you can see in this atom you can see the circles are nothing but they are the shells. If you take out one shell in the center, okay, so that is known as shell. Okay, the shell has going to have the subshells. So those subshells are nothing but S, P, D, and F, so on. So the diagram is not in larger way. So anyway, we are going to discuss these diagrams and everything in the upcoming lectures. So these shells are going to have S, P, D, F, and so on. Such kind of sub levels are there. You can call the sub levels as the subshells also. Okay. So next one is the orbitals. Orbitals are nothing but, so these are the shells. The shells contains subshells, okay, and so on. Let us consider these are the subshells. Okay, these subshells are going to have the orbitals. Okay, they are going to have the orbitals in this way. So these orbitals are going to have electrons. Okay, so first shells are going to have the subshells. Okay, these subshells are going to have the orbitals. Okay, in the orbitals the electrons are present. We will discuss in detail in coming lectures. So this is about the structure of an atom, and we have the few questions. The first question is, do all atoms have the same type of subatomic particles? Yes, each and every atom will have the same type of subatomic particles, but their number is not same. Okay, number is not same, but same type of subatomic particles. What are the type of subatomic particles? Like protons, neutrons, and also electrons. These three types of subatomic particles are present in each and every atom, but their number is not same. Okay, their number is not same. The number of protons is unique in each and every atom. Neutrons also unique, electrons also unique. So this is about the number of protons. This is about the type of subatomic particles in each and every atom. So next question is, why is an atom of one element differ from the atom of other element? Why they are going to differ? They are going to differ. Why? Because depending upon the atom. So due to the presence of different number of subatomic particles. So if you see here, the hydrogen and also helium, these are two types of the atoms. Okay, hydrogen is different, helium is also different. How they are different? Hydrogen has only one type of a proton, okay, and one proton, one neutron, and one electron. Okay, that is about the hydrogen. Okay, so here also you can see the helium is going to have one proton. Okay, it is going to have the two protons. Helium is going to have the two protons and also two neutrons and also two electrons. So you can see here the number is different, the same type of subatomic particles, but the number is different. Okay, the number of subatomic particles are different. So this is the reason how the elements are different from each other. Okay, next question is, how are the elements are distributed in an atom? The electrons, not element, the electrons. How the electrons are distributed in an atom? Okay, so electrons are distributed around the nucleus in the orbitals of a subshell. So just now we have seen. So the shells, okay, the nucleus, around the nucleus there are some shells. The shells are going to have the subshells. These subshells have the orbitals. In these orbitals the electrons are present. Okay, so we will discuss in detail in the coming lectures, and I hope this lecture is helpful to you. If you have any doubts or questions, feel free to post in the comment section and we will reply to your questions, and we will discuss the next topic in the next lecture. Okay.